Today we are going to see about signals and systems. So before you are going to study the signals and system, first you have to know about what is signal. So what are the basic natures? Similarly, what is system? Then what about the classification of systems? So first signals. So signals is nothing but a signal having some information. That signal can carry the information from one place to another place. That is called as a signal. So nowadays we are using more form of that is variety form of signals. Okay, electric signals and EGG signals, then EEG signals. So these are the best examples of signals. Then two types of signals. We know that two types are analog signals, then digital signals. So analog signals also called as a continuous time signals. Then digital signals also called as a discrete time signals. So this is also we can called by abbreviated as CT signals and TT signals. So continuous time signals. So here continuous time signals is continuously varying with time as well as amplitude. So without interval, the signal continuously varying. That is called as a continuous time signals. So continuous time signals as well as our discrete time signals. Discrete time signal is so signal will present at regular interval or irregular intervals. That is called as a digital signal or discrete time signals. Okay, this is whereas signal is present, that is only amplitude will be present. Here 0, 1, 2, 3, 4, 5. These are the signal levels. Only signals will present only these time intervals. So remaining timers, for example 0 to 1, within the place there is no signal. That's why there is 0. So here the amplitude is 0. So amplitude is 0. Okay. So this is sample numbers. These are the sample numbers. Okay. So our DT signal is time axis is denoted as n. Then amplitude axis is denoted as x of n. So x of n is your input signal. So also our continuous time signals x of axis is x of t. That is the amplitude of our y axis. Then x axis denoted as t, that is small t. Time is denoted by in our continuous time signal as t. So this is the comparison or then difference between continuous time and discrete time signals. So continuous time signal is continuously varying with time. So amplitude is continuously varying with the time. Then our discrete time signal is so continuously varying but regular at regular intervals. So continuously varying but regular intervals. So here our signal is so like signals. Okay. So next sampling. What is sampling? Why we are go for sampling? One of sampling method is used to convert our continuous time signal into discrete time signals. So another easiest way we can represent analog signal is converted to digital signals. That is, that technique is called as a sampling. So sampling process can be done by first our input signal is x of t. So x of t is our input signal, that is continuous nature. Then this is one delay element or impulse train. If you are adding impulse train pulse into continuous time signal, you will get discrete time signal, that is digital signal. That impulse train interval is n into t, capital T. So capital T is a period of interval, okay, or period of our cycle. So one cycle, okay. That is this is our sampling. Then elementary signals. So before you are going to classification of signals, first we have to know about some basic signals. That is elementary signals or standard signals. These signals are used to test our systems. That's why this elementary signals are very important. So first elementary signal is unit step signal. So unit step signal in continuous time nature we can represent u of t, that is u of t. So when is our unit time signal is will present or will exist, that time interval is up to 0 to infinity. So our time interval will be 0 to infinity. Our signal is present, at least amplitude is 1. That is called as a unit step signal. So remaining, that is t less than 0 in this time, our signal is 0. Okay. So minus infinity to 0, our signal is does not exist. So remaining time interval is 0 to plus infinity. Our signal will present at amplitude is 1. So that's why the signal is called as a unit step signal. So this signal look like a one step. Okay, one step. That's why this is called as a unit step signal. So unit step signal definition is, that is mathematically we can represented by u of t equal to 1 for which limit t greater than or equal to 0. So another one interval is, so two interval period is, and this value is 1. So remaining another one minus side, that is up to minus infinity, our signal amplitude is 0. So this is the classification, this is our mathematical representation of unit step signal. Okay, so this is graphical representation. So same u of t also can be represented in digital manner. So digital manner we can represent similar. So amplitude axis will be represented as or denoted as x of n. Then x-axis is represented in n, small n. So this is the difference between continuous signals and discrete signal. So discrete signal x of so this x-axis will be represented t, then dt is represented in n. Then amplitude axis in CT signals x of t, then dt signal x of n. So x of n will be present at a regular interval. Okay. So similarly, minus infinity to 0, our u of n value is 0. Then 0 to plus infinity of the n values, our amplitude will be 1 at regular intervals. So this is unit step. So next is our basic signal is unit ramp signal. So unit ramp signal definition is, there is a ramp signal. So ramp manner. Okay. So our amplitude and the time will be increased simultaneously. So time is increased 0 to 1, as well as amplitude also increased 0 to 1. Next level, if you are increasing time as 1 to 2, our amplitude also increasing 1 to 2. Okay, this manner our ramp signal will be rise going, that is exponential rising, like a rising signal. Okay, so mathematical representation of our unit ramp is ramp of t or r of t. R of t equal to t when which condition, t greater than or equal to 0. So greater than or equal to, sorry, only t greater than 0. So then less than or equal to 0 means our ramp signal is 0. So up to minus infinity to 0, our ramp signal does not exist. There is no amplitude. That's why I am representing 0. Then 0 after 0 up to plus infinity, our ramp signal will be present. That is t. So amplitude is t. So t, why we are putting t instead of 1 means, if you are giving t value 1 means that is simultaneously 1 and 1. Then if you are putting t value that is equal to 2 means increasing 2 to 2. Okay, time axis also 2, then y axis also 2. That is amplitude axis. Okay. So this is representation of impulse signal. So impulse signal, so unit ramp signal. Next our representation of impulse function. This impulse function also called as a impulse signal. So impulse signal we can represent in the term of CT signals. T that is x-axis, then del of t. So del of t is nothing but a delta function or impulse function. So if you are giving some delay in this delta function means, that is impulse function means, that is del of t minus 1 means our signal will start at 1. So that is positive 1. So this is delayed signal. Okay, delayed signal del of t minus 1. Amplitude is 5. That is representing amplitude is 5. Here unit impulse function, that is amplitude is 1. Okay, ma'am. That this is mathematical representation is nothing but del of t equal to 1. When which condition is del of t equal to 1 means, that is our t equal to 0 only del of t is present. Otherwise t not equal to 0 means signal does not exist. Both left side and right side signal does not exist. That is t not equal to 0. So next is some two properties of impulse function, that is scaling property, then sampling property, then replication property. These properties are used to solve your problems. Okay. So this is unit impulse train. So unit impulse train is this impulse train. If you are using sampling process means, there will be a very much use of your impulse train. Okay, so input signal x of t, then adding impulse train into your analog signal input signal x of t, then finally converted into x of n, that is dt signal. That is very useful of our sampling process. So this is impulse train. Impulse train is that is regular intervals, that is small n into t. So here time interval is n into t. Here small n value is 1. Here small n value is 2. Then up to etc. So 3, 4, 5. Likewise negative side. So minus 1, minus 2, minus 3, like that. Okay. So next is sinusoidal signal and the exponential signal. Sinusoidal signal is nothing but sine signal. Exponential also. So the representing exponential signal. So this is sinusoidal signal. Then the exponential signal e power at. So a is a real constant. Capital A is our amplitude. So real exponential signal and damper signal. So this is exponential signal. That exponential signal is representing decaying. So decaying exponential signal. Here rising exponential signal. So which waveform is rising from down to up means, that is called as rising. Suppose up to down means, that is decaying signal. That signal is called as decaying signal. Next is signum function. This signum function having three conditions: t greater than or equal to t is greater than 0 means 1, then t equal to 0 means 0. Then finally t less than 0 means minus 1. Having three different values. So that signal can be represented by mathematical representation. Then this is graphical representation. So minus 1 means t value is t less than 0. Then plus 1 means t greater than 0. So whatever t equal to 0, that is 0. So in between 0, that is signum function. So this is rectangular pulse function. So rectangular pulse function. So total period is capital T. So total period is capital T. Then time is divided into 2 half t by 2 minus t by 2 then plus t by 2. So amplitude is, that is 1 by 8. Okay, this is rectangular pulse. Then this is a unit triangle pulse. So triangle is minus 1 to plus 1, then amplitude is 1. That is triangle pulse. Then sync function. So sync function, only main lobe having maximum amplitude. So that is 1. So remaining side lobes having very lesser amplitude. That is approximately goes to 0. So next, discrete time signals. So discrete time signals, we know that discrete time signals is, that is sampling of continuous time signals. Okay. So discrete time signal is present only zeros and ones. We can represent 1 or 0. That is our representation of discrete time signals. So this is discrete time exponential, then sinusoidal signal. So this is exponential term, this is sinusoidal signal. So this is discrete time sinusoidal signal representation. So unit step function also we can see that already we got the in unit step in continuous time signals. So here also that is unit step function denoted as u of n. So whereas 1 is present, our interval is n greater than or equal to 0. Then 0 means n less than 0. Okay, this interval our amplitude is 0. That interval amplitude will be present 1. So next is unit impulse. So unit impulse only present is n equal to 0. Only our amplitude is present 1. N equal to not equal to 0 means our amplitude is 0. So unit pulse sequence. So that is unit pulse sequences with gas sampling properties, gas scaling property. So similarly scaling property also having that is replication and scaling property. Sampling property also having impulse function. Then operations on signals. So what is operations? Which operations we can perform our basic signals, that is time shifting, time scaling, time inversion, or time folding function, or this is also called as a time reversal function. So these three terms are called as same one. Okay, so time shifting, time scaling, time folding. So first time shifting. So what we do this perform the time shifting operation means we can perform time shifting by the delay operation, that is x of t. This is our input original signal x of t. That interval is present -2 to +2. Amplitude is 1. This is our given x of t. This signal have to shifted into time delay, that is shifting operation. So time delay is -t0. Here signal is x of t. Here we have to perform the x of t minus t0, that is delay function. Okay, delay operation or shifting operation. This is shifting operation, delayed function. So t minus t0. Same signal we can apply to minus t0. Okay, so minus t0 to plus t0. So we can same signal also shifted into delay operation, because this is positive shift. Positive shift means our total signal will be exist in the positive direction. That is positive position. Okay. So next time shifting operation will be advanced function. So first is delay function, second one is the advanced function. So time shifting can be performed by two operations, that is time delay and time advance. So advance means x of plus t naught. This plus can be simplified into minus of minus t naught. So minus t naught will be exist only negative side, that is minus t naught. So okay, minus of minus t is nothing but my plus t plus of t naught. So this signal totally or entirely will be exist in the negative side. Okay. Then time scaling. Time scaling will be performed by time expansion or time compression. So that is time scaling. Time scaling is 2t means y of t, that is output response, that is equal to x of 2 into t. So 2 is a time scaling. So our time scaling is present only time axis. Okay, does not amplitude axis, only time axis. So our time will be compressed. Okay, so 2 into t means we have to simplify the t divided by 2. So these are the t divided by 2. So here signal up to exist, input signal exists up to 3. Here signal up to exist smaller one. Okay, that is compression. So next, so our signal will be, so time scaling. This is signal will be, that is t by 3 means. So this is original signal y of 3t, that is 3t is nothing but a time compression operation. Time compression is original signal up to 3, then our compressed signal goes to only 1. So here time is up to 3, here time is up to 1. Time will be compressed, here time will be expanded. So t divided by 3 means you have to multiply the t into 3. So that is y of 3t operation. So that's why our time will be expanded up to 9. So next is time reversal operation. Only y of t equal to x of minus t. Time will be reversal. So here reversal means x of t. This is original signal. This is x of minus t. So minus t means totally signal will be reversed. That is mirror image. Time reversal or time folding. So here T2 is in positive side, here T2 is in negative side. So same signal in the folding operation. So discrete time signal also same time shifting, then time signal compression, then expansion. Okay, these are the basic classifications and basic elementary signals operations. What are the basic classifications of signals? That is continuous signals and discrete signals. This signals also called as analog signals and digital signals. So this signals, before you are going to classify our signals, we have to know about the basic elementary signals or standard signals. What are the elementary signals? Our elementary signals having many types. That is, first one is a unit step, unit ramp, then unit impulse, sinusoidal signal, exponential signal, as well as unit ramp signal. So these are the elementary signals. But these signals are used to test our system. Thank you. Next class we can see about classification of signals.